the Florida State University's High Performance Materials Institute. Director Dr. Ben Wang.
Whether it is tackling Mother Nature's fury or man-made failures, the High Performance Materials Institute is working to save lives and property with the strongest materials known to man. The research in nanotechnology, nanocomposites, and composites is cutting edge and is already offering limitless possibilities. To understand this research, you must think small, very small. If you have trouble threading a needle, then try working with particles 10,000 times smaller than a human hair. Think strong. Diamond is considered the hardest material, and yet these nanocomposites are even stronger. Think lightweight. A material 250 times stronger than steel, yet with a fraction of its weight. These particles are small, but they are having a huge impact on almost every facet of society.
Nanocomposites are like plastics on steroids. They're really strong, really light, and really safe to use.
Housed in a 45,000 square foot building adjacent to Florida State University's campus in Tallahassee, Florida, the High Performance Materials Institute has 13 laboratories constantly pulverizing, cutting, and breaking materials. The facility's labs, clean room, and classrooms are all equipped with state-of-the-art scientific, computer, and engineering devices. Partners run from A to Z, ATK launch systems to Zyvex, and from coast to coast, and include private businesses, government, and the military. Partnerships are one-on-one research relationships with complete confidentiality.
Our partners and sponsors are vital to us, and we conduct our research for our sponsors and partners to meet their specific needs. And often our research develops into something totally different which leads to something totally new advances that we discover along the way.
Resting on a hand, Bucky paper doesn't look very different from a sheet of carbon paper used in old typewriters. But the Bucky paper is made up of nanotubes. When the ultra-thin Bucky paper is used in composites, the amazing properties of the nanotubes are poised to transform aerospace, defense, electronics, energy, and infrastructure. This miniaturized version of an aircraft created at the Institute is coated with Bucky paper. As it is hit by lightning simulated by a stun gun, it shows its unique electrical conductivity properties, safely dispersing the electrical charge across the aircraft. In this computerized model of a Boeing 787 jet, the green line shows steel products, the blue is composites. Currently, a metal mesh is used to protect the aircraft from lightning. By replacing the metal mesh with the ultra-lightweight Bucky paper, which is 10 times lighter than steel, the aircraft becomes much more fuel efficient.
You want it stronger because it's safer, and then you want it lighter because that means that you're reducing the weight, and therefore you're increasing the payload, and then you don't need as much fuel and energy to move the vehicle that you're designing.
Planes, trains, and automobiles could all eventually use these extraordinary characteristics, revolutionizing manufacturing and the passengers' experiences. When even seconds matter on something as deadly as the spreading of flames, nanotechnologies are proving effective in preventing fires. Using Bucky paper's ability as a fire retardant is a cornerstone research project at the Institute. On the right-hand side frame, the material burns through in just 10 seconds. On the left-hand side, a full minute passes before the flame burns through the composite material. And if the heat source is removed, the fire would go out. This technology could save lives by preventing fires on ships, aircraft, and other structures. Soldiers in war zones could see two other uses of nanocomposites. Protective gear, like helmets and body armor, can be created incredibly strong, yet lightweight. A Bucky paper flak jacket could stop the impact of a bullet, yet be as lightweight as a t-shirt. And in partnership with St. Petersburg College in South Florida, 3D imaging of soldiers before they head into harm's way is providing a high-resolution and permanent picture of a human body, in particular arms, legs, and hands, to create prosthesis in the event of injury or loss of limbs.
We're working towards making prostheses using advanced composites that are stronger, lighter, and smarter, and much more comfortable for our wounded American heroes.
Everything has a breaking point, but when and where is it? Composite materials can make bridges stronger and safer. Stress sensors can also tell engineers where a bridge is weak and when it has reached that danger point.
We like to know where our red flag in the material is, where its breaking point is. And in order to do that, we have to test it on a small scale, like with a material testing system that we have behind me. That way we know whether 200 pounds will break a bridge or whether 500,000 pounds will break a bridge.
The High Performance Materials Institute has access to equipment totaling more than $10 million. What once looked impossible to cut is sliced away in just minutes under the powerful water jet cutter's blade, hacking through steel in minute detail. The tiniest particles come alive under the scanning electron microscope and the transmission electron microscope.
So if you remember your high school microscope that has 10 times or 100 times magnification, this equipment can go to 100,000 times magnification or even more, which allows us to look at the microstructure of any material in the world.
Energy efficiency is a core goal throughout the research, so recycling the materials created is never forgotten. A green lab is devoted solely to how to reuse composites once they have served their original purpose. Research is still in the early stages, but the sky is the limit, or more appropriately said, in this case, the outer limits. Once harnessed and mass-produced, Bucky paper could create the science behind the once science fiction space elevator, traveling 42,000 miles into outer space. The High Performance Materials Institute truly takes ideas from concept to prototype and beyond.